I'm going to start this by assuming you've read the first couple of pages of chapter 2, and we're going to develop specialization through the idea of comparative advantage. So we'll start developing comparative advantage, then specialization, and then the advantages of specialization. The definitions are here and in your book, and we can use these ideas to compare different individuals, different firms, different countries. Those are the most common entities. But that's quite a jump from the individual to, say, a country, but these ideas can be used in both cases. Let's start with the idea of individuals. So you could have someone that has an absolute advantage. So if we think of LeBron James, we could think of he has an absolute advantage in many aspects of athletics. And he might even be a better 800-meter runner than many athletes in the world. But it would be ridiculous to have him running the 800 in the Olympics when he's relatively much better at basketball. So LeBron James may be better at everything, so to speak, but that doesn't mean he should be doing everything. He should be specializing in basketball. If you don't know basketball, then let's take another example, say two singers. So Ariana Grande and Taylor Swift. And well, who really wants to listen to either of those? Well, all right, let's take those two. So Ariana Grande and Taylor Swift are two singers, but Taylor Swift may have a comparative advantage in singing country music. She doesn't sing it anymore, but she did once. And so, in terms of a relative sense, you could say that Taylor Swift has a comparative advantage in country music and Ariana Grande and some other kind of music, pop stuff. And who has an absolute advantage? Well, maybe that's a little hard to tell. I mean, Ariana Grande does have a very good voice, whatever one may say about her. I mean, she is who she is, but she does have a very good singing voice. So anyway, those are two kind of ideas of absolute and comparative advantage concerning two individuals. So here we have a table of how long it takes each person to do each task or produce each service. Now this assumes one is better at web updates and one is better at bicycle repair. So these numbers are rather arbitrary and they are just used to illustrate that point. Now we're going to move that from that to the next table, which is in your book. And that is the table of opportunity costs. Now it's fairly simple in terms of the numbers to go from one to the other, but if you haven't done this before, it might not jump out at you what's going on. So let me just take a minute because we're going to use this lower table or tables like this quite a bit. And so once you get this in place, it's fairly simple then. And again, the whole idea is fairly simple, but you can trip up if you don't do this systematically. So, all right. So we're interested here in the idea of one web update for each individual. So we'll start with Mary. Well, it takes her 20 minutes to do a web update, but only 10 to do a bicycle repair. So in the time that it takes her to do one web update, she could have done two bicycle repairs. Hence, the two is in terms of the next best use of her time. By using the same reasoning, you could get Paula's opportunity cost for web updates, which is one bicycle repair, and then you just go the other direction to get the opportunity costs of bike repairs, that is, what you're giving up in terms of web updates. So that's really all there is to that. Now here we have one other table, and that is the table of hourly output. And sometimes the numbers will be presented to you in this form. So in other words, you won't even have the production times. So you might not even have that. And all you'll have to work with is the hourly output. So you're going to want to get used to how that works here. Again, the arithmetic here is fairly straightforward. So if it takes Mary 20 minutes to do a web update, and where did we get that from? Well, that's the information we started from. Well, in an hour. So that is in terms of the hourly output. She can do 3 updates in an hour. That is, Mary can do 3 updates an hour. Now, Paula, it takes her a half an hour, and therefore she can do 2 updates in an hour. That's for Paula. And then you can go from that information to the table of opportunity costs as well. So, for instance, from the hourly output table here, in an hour, Mary can do 3 updates, 6 bike repairs. So every time she does 1 web update, it's costing her 2 bike repairs. And then for Paula, every time she does 1 web update, it costs her 1 bike repair. Now, it may be easy enough to just look at these numbers and see what's going on, but it's often useful to just think systematically in terms of the ratios. So, if you want to get the opportunity costs out of the table of hourly output, that is, if you want to go from the lower table to the table of opportunity costs on the previous page, well, you can just think of this in terms of ratios. So, for instance, 3 web updates here is to 6 bicycle repairs, as 1 web update is to how many bicycle repairs? So what we want to do is get this in terms of the opportunity cost of 1 web update. So 3 to 6 equals 1 over x. 3x equals 6. X equals 2. So pretty straightforward, but I think it's always useful to just get a systematic method, and then you won't get tripped up, because it can happen that you get the numbers reversed and then everything is reversed and you get the wrong answer when we get to solving problems with international trade. But as long as you start out systematically, and again, some of you are wanting to just do the numbers in your head and go ahead, but that's up to you. The more systematic, the less chance of error in my view.